Hey, welcome. This video is on graphing nonlinear functions, part 2. There was a previous video, graphing nonlinear functions. It got a little bit long, so I kind of ended that one early and I decided to make a second video so that first one wasn't so lengthy. This part is on piecewise functions, also called piecewise defined functions. We'll just call them piecewise functions here. So what is a piecewise function? It's a function that is defined by more than one equation, each having a different domain. Here's an example. Notice that on the right, there's two rows. So it's f of x equals x plus 1 if x is greater than 0. That's the top row. And then the bottom row is f of x equals negative x squared plus 2 if x is less than or equal to 0. So we have two conditions. There's going to be two separate graphs here. They may or may not join, but we have two different graphs here. Okay, so the domain of each piece, probably why it's called a piecewise defined function, the domain for each piece is specified. And when we choose values for x, they must be in the domain. So when you make your table, you have to choose values that meet that condition. So for example, this top row says x is greater than 0. So when you make your table, you can only choose numbers that are greater than 0, like 1 and 2 and 3. But actually, we're still going to pick 0, because what about 1/2 or 1/3 or 0.1? Those are all greater than 0. Or 0.0001. You get what I'm saying? So we're still going to put 0, but we'll put notation there to show that it's not included. And the bottom row says f of x equals negative x squared plus 2 if x is less than or equal to 0. That one has the equals, so we can pick 0, but also other numbers that are less than 0. Negative 1, negative 2, negative 3. So when we make our table and pick points, they have to be in that condition. They have to be numbers that meet that condition. Okay, the constant or the number where the graph begins is called an endpoint. So in this case, the top row and the bottom row each have an endpoint at 0. So it's whatever that constant is, whatever that number is. If the domain is x is greater than or equal to 5, then our endpoint will be at 5. There's no other endpoint because x greater than or equal to 5 it goes from 5 to infinity. It doesn't end. That's why there's only one endpoint. However, if our domain has an x in the middle, such as this, negative 2 less than x less than or equal to 7, this one has two endpoints, because x is only between negative 2 and 7. So therefore two endpoints. This one does not go on forever to the right or the left. Okay, so what about these endpoints? Well, we're going to show the endpoint using a small circle. It's very similar to interval notation. In interval notation, we use brackets to show the number is included. There's an equals. We use parentheses to show that that number is not included. Well, same thing goes here. If there's a greater than or less than, we're going to use an open circle. And if there's a greater than or equal to or less than or equal to, we're going to use a solid circle or a closed circle. So if it has a line on the bottom for equals, you fill in your circle. If there's no line on the bottom, you leave an open circle. Okay, here's our first example. Now this one's not a piecewise defined function, but what we're going to do is we're going to build up to it. So that's what this is right now, is we're just getting ready for those piecewise defined function. This one just has a restricted domain. So the graph is f of x equals 2x minus 3, but there's a condition, and that's that x can only be bigger than 0. So we're going to pick points. We're going to pick points that are in this restricted domain for this function. And 0 is going to be our endpoint. So we're going to pick 0. Now we could only also pick numbers that are bigger than 0. Well, what else is bigger than 0? Right, 1 and 2. So those are the numbers we'll pick. We could pick more if we want, but that's good enough. 3 points should be good, right? Now we also want to note if this is going to be a solid circle or an open circle. It doesn't have the equals, so what is it going to be? Right, an open circle. So I put a little open circle. It was kind of big, but I put a little open circle next to the 0 just to remind me that it's going to be an open circle on my graph. Okay, let's plug in those numbers into the function. You could use your calculator or do it by hand. So plug in 0, what do you get? 2 times 0 is 0, and then 0 minus 3 is negative 3. Right? Remember, you could always pause and work it out on your own. Then plug in a 1. 2 times 1 is 2. 2 minus 3 is negative 1. And one more, plug in x equals 2. 2 times 2 is 4. 4 minus 3 is 1. Okay, plot those points. So 0, negative 3, 1, negative 1, and 2, 1 on your graph. Yeah, that looks good. And then we're going to draw a line. This is a line, right? F of x equals 2x minus 3. There's no exponent, so it's a straight line. But at the point 0, negative 3, that's an endpoint. So we're going to use an open circle on that side and then an arrow in the other direction. So that's what it looks like. So make sure you have an open circle at the point 0, negative 3. And the other side should have an arrow on it. All right, here's our next one. F of x equals negative x squared plus 2 if x is less than or equal to 0. All right, well, let's pick points, right? We're going to start with 0. That's our endpoint. So we're going to start with 0, and that's going to be a closed circle or an open circle. Right, that's going to be a closed circle. And then we're going to pick numbers that are less than 0. Okay, so I'm going to pick 0. I put it towards the bottom because we're going to pick numbers that are smaller than 0. It doesn't matter how you do it. Maybe you're using a graphing calculator and you want to see the numbers in order. So it's up to you how you put them on your table. Closed circle, right? Okay, now what other numbers should we pick that are less than 0? Negative 1, negative 2. I think that'll be good enough. You could always pick more. There's no maximum number of points you could choose. You could always choose more if you're unsure what it looks like. All right, let's plug in each of those numbers. If you plug in 0, you should get 2. Remember to do exponents first, and then the negative in front of that x squared, that comes second. So 0 squared is 0. Then it becomes negative 0, which is still 0, plus 2 gives us 2. Then plug in negative 1. Negative 1 squared is positive 1, and then that negative in front stays negative. Or if you use your calculator, just remember when you replace a variable with a number and that number is negative, to put it inside parentheses. The negative would stay outside the parentheses. That's in front of the x squared. Okay, so for -1, you should get +1. And for -2, you should get -2. -2 squared is +4, but then there's a negative in front that makes it -4. -4 plus 2 is -2. Okay, let's also think about what this graph looks like. Plot the points. There's our points. Looks almost like a line, but not quite, right? Let's see, look at the graph and know what shape it should have. X squared, that's a parabola. It's got a negative in front. That means the parabola is going downward, right? So just try to make it have that U shape downward. And at 0, it's going to have a closed circle. So the point 0, 2 is a solid circle. And then the parabola is on its way down. So it's only like half of the graph, right? Okay, our next one, f of x equals the absolute value of x if x is less than 1. So absolute value. Do you remember what the absolute value looks like? Right, it has that V shape. It looks like a V. It's a positive in front, so that means the V is going up. If there was a negative in front, the V would be going downward. All right, so let's pick our points. We're going to start with 1. That's our endpoint. And are we going to have a closed circle or open circle? Right, open circle. And then we're going to pick numbers less than 1. 0, -1, -2. That should be plenty. There's no maximum number of points. You could always pick more points just to be sure what it looks like. All right, plug those in. The absolute value, what the absolute value does is whatever you plug in, it just makes it positive. So when you plug in 1, you just get 1. Plug in 0, just get 0. -1 just makes it positive, gives it 1. Plug in -2, +2. Yeah, not bad. All right, plot those points. Looks good. I could tell that's a V shape, right? Can you? Yeah. Okay, now at 1, 1, at that point, so before you draw on your graph, make sure you put that open circle so you don't put your arrow going in the wrong direction. The other direction will be the arrow, right? All right, so open circle at the 1, 1, and then draw it in, and an arrow going to the left. Almost looks like a backwards check mark, right? All right, example 4. So this is actually a piecewise defined function because there's two pieces to it. So f of x equals -2x plus 3 if x is greater than 0, or f of x equals x squared if x is less than or equal to 0. Right, well, let's see, we have two graphs to do. I think we should do one at a time, right? Does that sound easier? Let's just concentrate on one at a time. So just write the top row separately. And now we're going to do exactly what we were just doing on the previous examples. So make a table. And then what number are we going to start at? Yeah, we're going to start at 0. And we're going to pick numbers bigger than 0. So 1 and 2. And at 0, open circle or closed circle? Open, right. So now plug those in into our equation. So if you plug in 0, -2 times 0 is 0, plus 3 is 3, etc. So keep working those out. Plug in 1, we should get 1. and plug in 2, you get -1. -2 times 2 is -4, and then -4 plus 3 is -1. All right, this is a line, right? There's no exponents, no absolute value, no square root. So plot those points. 0, 3, 1, 1, and 2, -1. That looks good. Make sure at 0, 3 to put the open circle and then your arrow going the other direction. So it should look like that. All right, that's half of it. We're halfway there. Let's do the other half. F of x equals x squared if x is less than or equal to 0. All right, make a table. We're going to choose 0. And you can put the 0 at the top or the bottom. It's up to you. But we have to pick numbers that are less than 0. Oh, and pick numbers that are less than 0. And we should also put if it's an open circle or closed circle. Yes, closed. Okay, what other numbers should we choose? Right, -1 and -2. Okay, work those out. If you use 0, you should get 0. And -1, -1 squared is +1. And -2 squared is +4. This is a parabola. Don't forget what it looks like. So plot your points. That looks good. 0, 0, -1, 1, and -2 up 4. It's a parabola, so it's got that U shape. Make sure at the 0, 0 you use a closed circle. So in a piecewise function, it's very important that you have, that you have one of them an open circle and one of them a closed circle if one point is above another point. So notice the 2 points we have here at 0. For the first graph, we have a point at 0, 3. And at the second graph, the bottom graph, we have 0, 0. Remember the vertical line test? You must be able to draw a vertical line anywhere through the graph, and it can only intersect at one point. So if I were to put x greater than or equal to 0 for the top graph, then they would both be closed circles. And if you have two closed circles, if you draw a vertical line through those 2 points, it would intersect twice, and therefore it would not be a function. So it's critical that you do not have two closed points above each other, one above the other. All right, it's still a function. It's not connected. It's not a continuous function. It has two separate pieces, but it's still a function. Again, called a piecewise defined function. Let's do one more. All right, f of x equals x minus 2 cubed if x is less than 3. And then f of x equals 5. Yeah, just 5. If x is greater than or equal to 3. Okay, again, one at a time, right? You should also think about what this graph looks like. Is to the third power. We did some graphs previously that were to the third power. It kind of has like a S shape, kind of flipped and sideways. I don't know how else to describe it. All right, let's make a table. And x is less than 3, so we're going to start with 3. And then we've got to pick numbers that are less than 3. So how about 2 and 1 and 0? And then at 3, we're going to put a open circle. Okay, so 3 was the number we're starting with, but we have to pick numbers that are less than 3. All right, plot those, or I'm sorry, plug those into the equation. You could go in any order. For 0, you get -8. 1, you get -1. 2 is 0, and 3 is 1. Let's plot those. Yeah, so remember that's what a cubic function looks like, but it's missing the other side to the right, so it's only part of it. Anyways, let's kind of draw that. Don't forget at 3 to use an open circle. All right, now the second function, 5. F of x equals 5. It's just a number. Remember, f of x is just a number. F of x is just y. If I wrote y equals 5, what kind of line would that be? Yeah, if you said horizontal line, you would be correct. F of x equals a number is just a horizontal line. But maybe you're a little, confused. We can still pick points, no problem. Okay, so we're going to pick 3, closed circle, and then some other numbers bigger than 3. How about 4? How about 5, right? Now, there's nowhere to plug those in, is there? No. So the y value is simply 5, 5, 5, 5. So this may help. You don't really have to do this, but I wanted you to see, like, you can still plug in points. There's just nowhere to plug it in. All right, plot those points. At 3, we're going to have a closed circle. And then we're drawing that horizontal line to the right, so the arrow on one side. Okay, so the examples that we did, there was only 2 parts to it. These can get more complicated. There could be 3 or 4 parts to a piecewise function. And some of them could be in the middle. So you could have an outer piece and a middle piece and a piece on the right. For the examples I did today, there's only a left side and a right side. And I think that's okay for right now. Maybe this is the first time you're seeing piecewise functions. This is kind of intended for an algebra class. If you take pre-calculus, you'll see more piecewise functions. So to me, I think it's a little bit of an intro. They do get more complicated, but this is as far as we're going. Okay, that's it for this video. I'll see you here for the next one. Have a good day.